Hi everybody, thanks again for joining us today and welcome to today's webinar. I'm Lindsay Teal and I'll be your host today, and the session should last around 40 to 45 minutes. We're joined today by my colleague Rob Snaith, and Rob is one of the Specialist Energy Implementation Advisors here at Resource Efficient Scotland, and he's worked with organisations across Scotland to help them implement successful energy efficiency initiatives, so he's going to share some of that experience with us today.
Thank you, Lindsay.
Just before that, sorry, if you've got any questions throughout today's session, then you'll see on screen now that the questions box is there. So at any point, just type your question in there and we'll stop at 2 points throughout today for Rob to answer those questions. And if we don't get to answer them all, then don't worry, we'll follow up with you at the end of today's session. And also, if you enjoy tweeting, then do so to @ResourceScot, and you can use the hashtag ResWebinar. And if you want to use that for posting your questions as well, then do so. And so, yep, with that, I'll hand you over to Rob.
Thanks very much, Lindsay, and thanks for everybody, for dialing in. What we're going to look at today is, as you see here, why looking at space heating is important. It's one of the biggest costs that most businesses have. A few little points about understanding what your current energy use is for space heating and how to analyse that. Then we'll have a look at the top 10 issues and ways to address those issues which have come up in a lot of the work that we've done. And then we'll have a quick chat about how Resource Efficient Scotland can help you to take the next steps after today and look at reducing your own heating use. Sorry, I'm going the wrong way there. Okay, this is a very kind of simple slide here. Why should we be looking at our energy use? The green line is for the retail price index, which is the general measure of inflation. And as you'll see from the orange line, energy prices have vastly outstripped that. The line here is for domestic energy, as you see, but small to medium enterprises energy prices are very similar. So, as I said before, energy and heating especially is usually the largest and most visible cost for most organisations. So it makes sense for us to try and tackle that as much as possible. Why is it important to understand your current energy use? There's no way that you're going to be able to start making savings if you don't understand where you're spending money in the first place. The first thing that we say to every organisation that we speak to is to get a good idea of what your energy use is, to analyse that data, and then you can start setting targets and looking at ways that you can reduce that cost. We're going to kick off with a quick poll here, so I'll hand you over to Lindsay.
Yeah, so sorry. So coming on screen now is the first of the polls that we want to run, and it's how effectively does your organisation monitor space heating consumption at the moment? So the options there on screen are A, very well, B, well, C, okay, D, not well, and E, very poorly. So if you could just take a couple of moments to complete that, then it'll just give us an indication of where you're at currently. So most people are taking the time to do that now, and maybe not so surprisingly, a lot of people are sitting at the not very well and very poorly end of that spectrum.
Absolutely, which completely reflects the experience that we have with working with organisations through Resource Efficient Scotland. It's not a difficult thing to begin to get to grips with, but it's taking those first few steps and understanding what you actually need to do to have a good idea of your energy use are the most important things, which we'll chat about in the following slides after the poll's completed.
So I think most people have completed that, so I'll close that poll there and I'll just share the results with you. So it's 0% feel like they're doing it very well, so hopefully maybe you'll be able to click that button at the end of the session. The 12% well, 28% okay, 44% not well, and 16% very poorly. So definitely room for improvement there.
Absolutely.
So you're in the right place. So I'll just pass the slides back over to Rob.
Okay. Heat use generally, I mean, you see here the three types of heat use that there are. You've got convection, conduction and radiation, and you can get heating systems which use all of these types basically. Getting an idea of why what the people's different levels of thermal comfort are is also a very important thing to do as a simple kind of staff survey. you can see the different factors which have an effect on what make people feel comfortable within any kind of organisation, within any building. Also the different sources of heating you've got in your organisation. People themselves generally release, we say normally about 100 to 120 watts into the atmosphere. You've got the thermal mass, the building itself, the heat that's stored in the structure of the building. Insulation, which is heat from the sun. So if you've got large windows in your building, then you're going to have a lot more heat coming in than if you've got smaller windows. IT equipment, cooling equipment, refrigerators, cooling fans on fridges and things, they extract the heat from inside the fridge to keep your food cold, and that heat has to go somewhere. Generally it's just kind of kicked out the back into the building itself. Process equipment if you have heavy plant or machinery, and finally your actual heating system, which is kind of on top of all of that as well. There's lots of different sources of heat coming into a building, so you need to be aware of where everything's coming from before you can start to get a grip on kind of how you're managing that. Understanding the way that energy and heat in particular is measured is also an important thing to enable you to have a good understanding of what the possibilities of a reduction are. Energy is measured in kilowatt hours, kWh, and 1 kilowatt hour is the same as 1 unit of electricity on your bill. For gas bills, your gas bill will generally be measured in meters cubed of gas, and there's a conversion formula on every gas bill to show you how that's been converted into kilowatt hours, the standard unit of energy. If we look at the gas example there, if you have a 27 kilowatt domestic gas boiler, that would be a large domestic boiler or a small commercial boiler, running at a load rate of about 30%, then the power rating of that boiler running is 8.1 kilowatts. If that runs for an hour, you've used 8.1 kilowatt hours. And then from your bill you'll be able to see what your charge per kilowatt hour is, and you can have a good idea of how much your heating system is costing you. So the initial inspection of just purely your bills is the first step to take, and kind of making a note of that data and monitoring it over a period of time is the best way to begin to identify trends and see where there might be issues in your energy use. What kind of data should you collect? Like I said, recording your usage from your bills is the simplest way to do it. There are more sophisticated metering technologies which you can install, automated meter readings, half-hourly meter readings for larger energy users also. And if you can collect at least a year's worth of data, preferably kind of longer than that, over 3 years generally is a good starting point to be able to identify trends in your energy use. If you look at if you've got hot water use in your organisation as well, generally about 10% of your heating energy will be going towards hot water use. So as you can see from the graph there, once you've started to gather that data, you can start to build up a picture of, hopefully you should be seeing a lot more heating in the winter times, but if you can see any kind of aberrations or trends which aren't as you would expect to see from that graph there, that's where you can start to target any improvements that you might be able to make. Electric heating it's a very expensive form of heating. It's not as prevalent as it has been for the last kind of 20-30 years or so. It's beginning to be phased out a bit now, but I'm sure it won't be an uncommon idea to a lot of people, the electric storage heaters, direct electric panel heaters. One of the difficulties with electric heating is obviously every organisation will have general electricity use as well. So if you just have one bill for your electricity, it sometimes can be hard to identify which of that use is going towards heating and which is your general lighting and appliances and things like that. So as a general rule of thumb, it is fair to assume about 50-50 for most small to medium organisations. So it's just another factor to be aware of when you're thinking about what you might be able to do. So now we'll go on to the top 10 tips, the things which have kind of come up most commonly in the organisations that I've helped and we as a programme at Resource Efficient Scotland have been working with. The first one, we've touched on it already, monitoring. It's the most important thing that any organisation can do, is just to to get a good idea of where your energy use is, and any trends and any kind of aberrations which you can begin to look at. A few very little simple things that you can do. Just record the settings that you've got on your system. A simple kind of record sheet. Change the settings, change the temperatures on the thermostats, record the date that you've made those changes, and you can see how it has reduced or increased your energy use over a period of time. Something as simple as putting dates in the diary to clock changes. So you know, for Christmas holidays or any other days where you know the business isn't going to be working, you don't want to be heating your space in a time when it doesn't need to be. Another nice little test that you can do is looking at weekend use. If you're not operational over the weekend, just record the weekend use for a few weeks in a row, and then do a test weekend. Let everybody know that you're going to be recording the weekend use that time, and ask everybody to make sure that absolutely everything that can be turned off over the weekend is turned off. And then from that you'll be able to see what the difference is between the standard status quo, and potentially kind of target some changes to be made to reduce your general energy use. The second point is benchmarks. Benchmarks are a way of measuring yourself against other organisations within your sector, so you can see what the expected energy use for your type of organisation would be, and see where you come up against that. Helps you, as I say, understand your current costs in the context of your wider sector. Helps you set targets if you want to bring yourself down to the benchmark or below the benchmark. It's a nice focused way to target yourself. You can get a good idea of how much it is possible to save. We go into a lot of organisations and they say we've been given a target of saving 15% of our heating costs over the next 1, 2, 3 years. And then if you look at the benchmark and they're already at or about the standard for their sector, then savings of that level just aren't going to be possible. So it helps to keep things in perspective as to what you might actually be able to do. And they're a useful way to begin conversations with decision makers, people who might be kind of making the decisions on whether or not to invest in a certain piece of energy saving kit. If you can say, this is where we are, this is where we ought to be, then you can begin to make the case for that investment. For larger organisations, degree day benchmarks are something else to look at. Degree days are generally a way to measure your heating use against the external temperature over a number of years. So you can see how your building has been performing, how your organisation has been performing against not only the general sector expectations, but the climate expectations as well. So you can also it's the next level of identifying any kind of trends which might be out with what's expected. Just a few examples there of standard benchmarks. CIBSE is the Chartered Institute for Building Service Engineers, and they produce the general benchmarking figures for most of the organisations in the UK. So you'll be able to have a look at that list and see if you kind of compare. If you've got a good idea of your energy use already, you might be having some alarm bells ringing, or it might be an exercise for you to go away and kind of have a look at that. These figures here are measured, as you'll see, in kilowatt hours per metre squared per year. So that's units of energy per metre squared in your building per year. So that's, again, with a little bit of analysis of your bills at the very top level, you should be able to get yourself a rough figure and see where you compare with those. Next tip, improving the thermal performance of your building, insulation, basically. There's a few different areas of a building that can be insulated. The main two are the roof and the walls. Generally, we'll say any building will lose about 20% of its heat through a completely uninsulated roof. The different ways of doing that obviously differ for individual buildings. You'll see a few of the kind of the standard ways in the pictures there. Just laying down simple mineral wool material in a loft. The picture on the bottom left there is a sprayed insulation material. It looks a bit like the old expanding foam you used to get. It's the stuff they use now is not the same as that. You'll be happy to hear, because that did lead to quite a few issues with dampness problems and things like that. There's lots of materials available now which are breathable, so they allow moisture to pass in and out of the building as it's meant to, yet still retain a lot of the heat within the building. This really improves the thermal performance of the building. Wall insulation is the next big one. Generally, we'll say about 15% of a building's heat will be lost through the walls. Cavity wall insulation is probably the most popular one, or the most kind of common measure installed in the UK at the moment. If your building's of brick or block construction with a cavity in between two layers of brick or block, and most buildings built from about the late 1920s up till the late 80s, early 90s will be of that construction in the UK. Then you can fill that gap in between, again with a breathable material, which still allows any moisture to flow in and out of the building as it's required, but really improves the thermal performance of your walls and makes a big difference in how warm the building is. The one issue that you do need to be aware of with cavity wall insulation, if you are in a very exposed location, so the far west coast, out on the island somewhere like that, or up on the north coast, then driving wind and rain can still cause a bit of an issue with cavity wall insulation, purely because of the moisture ingress and egress from the building, which is required in those conditions. So any cavity wall insulation installer should be able to make sure that your building is firstly suitable, it's of the right construction, and it's in an appropriate location to get that work done as well. Older buildings with solid brick or solid stone walls, insulation is a bit trickier. It's not a low-cost measure anymore when you get to that type of construction. It can be an expensive thing to do. Can still be a very worthwhile thing to do. It's really down to a case-by-case investigation as to the kind of the cost benefits and how long that type of work is likely to pay, but it's definitely something which can be done and which we've done quite a lot of work with as well. On to the next tip, looking at replacing your heating system. Basically, if you've got a boiler which is anywhere between 15 and 20 years old, it's probably going to be beginning to decline quite rapidly in its efficiency. So looking at replacing that, the different options of replacing your heating system is probably one of the biggest savings any organisation is likely to be able to make. When do you upgrade your boiler? You can check your boiler efficiencies for the vast majority of small commercial and kind of large domestic, which kind of feeds into a lot of SME size organisations. You can check the efficiency of them on a government website, which we'll have a link to in one of the following slides, I believe. Generally, the age of the boiler is a good indicator. If your boiler's been well looked after, if you've had a maintenance check done every year, then we would normally expect a standard gas or oil boiler to last about 15 years before it starts to drop off quite rapidly in its efficiency. If you're getting to that stage and you're finding you're having more and more issues with maintaining the boiler and having to get people to come out and look at it, then that's obviously a bit of a clue that things maybe aren't running so well, and it's about time to start thinking about upgrading. There we go, that's the website I mentioned earlier, the Performance Characteristics Database, PCDB. So you can just pop in the make and the model of your boiler and it'll give you a rough idea of how efficient it will be working at the moment. As we say, there are many SMEs, the vast majority that we speak to are using domestic size boilers. So that's where the information that you can find on that kind of range of technology is. Any new boilers now in the UK, any new boilers that are installed have to be A-rated, which means they're more than 90% efficient. And that legislation came in the late 90s, as you see there. Anything installed previous to 1997, they are likely to be not as efficient as a brand new boiler could be. The most efficient type of standard boiler you can get at the moment is a condensing boiler, which basically some of the flue gases, rather than coming straight out into the atmosphere, are condensed and taken back in and burnt again in effect, so you're getting a higher level of efficiency. You're getting kind of more bang for your buck for the fuel that's going through that boiler. So they're going to be up to 92-93% efficient for those types of boilers. With a condensing boiler, you do have to be quite careful with where it's placed. It has to be placed on an external wall, because there's a condensate pipe which needs to come out of the external wall as well. So you need to make sure that the location for your boiler is appropriate for that technology. Looking at switching the heating type, so rather than just replacing an old gas or oil boiler for a new gas or oil boiler, which will give you an improvement in the efficiency of your system, looking at possibly switching fuel to a lower cost, lower carbon emission system is something that we advise a lot of organisations on as well. There's a few different kind of options, and I think we're going to go to another round of questions now to see if anything's come in.
Yeah, sure. I think you've kind of really answered this question a little bit. Someone was asking how old does their boiler have to be before they should think about replacing that. But I think you really have addressed that.
Sure.
That question. And another one is that they've heard biomass boilers can be unreliable, and is that true? Again, maybe you're going to touch on that in a second, but you might want to answer that briefly.
Sure. Yeah. I mean, any boiler, any piece of kit can be unreliable. It depends on generally the rule is you get what you pay for. There are different makes and models available, and there are top of the range ones and not so top of the range ones. Generally, if your boiler is installed by a suitably qualified professional, and for every different type of system there are accreditation lists that you can go to find your installer. And if you have an annual maintenance contract, so the boiler is looked after properly to make sure it kind of runs well, then there shouldn't really be a problem. Again, touching on the first question as well, if you've got a maintenance contract, then any kind of standard boiler should be able to run effectively for up to about 15 years, we would expect.
Great. Someone's asking, where can they find out more information about benchmarking?
About benchmarking, the CIBSE website is a good one to go to. That's the Chartered Institute for Building Service Engineers. Also, it's a lot of the CIBSE documentation you do have to register for, but there are a few kind of free bits and pieces on there as well. A good thing to do is just to speak to somebody like ourselves, independent consultants, who will have a good idea of where you sit and good experience with working within the different sectors as well. So I would say speaking to people like ourselves and just that general CIBSE website are probably the best two places to go.
Excellent. Thanks, Rob. Someone's also asking if the slides will be available at the following the webinar, and they will. We'll also share the recording and the slides, but we'll move on now. I think I'm just going to run another quick poll, and it's really building on just the swapping of heating type that Rob's going to move on to, and we want to just ask people, what heating type do you currently use? So on screen now you'll see that the options are electric, natural gas, oil, LPG, or some form of renewables, so whether that be air source heat pumps, ground source heat pumps, or solid fuels such as biomass. So natural gas is the winner at the moment.
As we'd expect, yeah. It's the biggest heating fuel used across the UK. Where there's natural gas available, it's generally the cheapest option. Renewables change that equation a little bit with a UK government scheme called the Renewable Heat Incentive, which I'm sure some of our audience will have heard of, but I'll touch on a little bit later on. They changed the economics as it's a financial benefit from the government for using a clean heating source, which does bring them in line with natural gas. But generally, if natural gas is available, it's going to be the cheapest way to heat any building.
Great, and so I've just shared those results on screen with you now. 35% electric, 50% natural gas, 5% oil, no one LPG, and 10% renewables. Something of interest as well might be the biomass webinar that we had last week, where Seamus went into much more in-depth detail about biomass boilers. So if you are considering renewables and biomass is one of your options, you might want to check out that webinar. Okay, so I'll hand the slides back to Rob, and if you've got any more questions, then don't forget to pop them in the questions box, and we'll stop again at the end to ask a few more questions of Rob. Thanks.
Okay, well, yeah, as I mentioned there, if you're on a high price fuel such as oil or LPG, then replacing that with a renewable system it really makes excellent financial sense. Or obviously, if you're able to have a mains gas connection and you don't currently, then that's definitely something worth looking into. You can speak to Scotia Gas Networks are the best people to speak to about getting that connection set up. getting yourself a natural gas connection can be an expensive business. It really depends on kind of where the pipes are running nearby to you, and just what's going to be involved in extending that pipework into your organisation, into your building. The other alternatives for fuel switching, as Lindsay mentioned, they are generally renewable options, biomass, which is burning wood in the shapes of pellets or chips or logs, or heat pumps, ground source or air source heat pumps, which heat pump technology is basically the same as a refrigerator, but in reverse. So where the fridge is extracting the heat from the box inside where all your food is, and like I said earlier, the fridge just kicks it out the back, what a heat pump does is extract the heat from the outside atmosphere. A ground source heat pump has coils underneath the ground, so it extracts the heat from the moisture in the ground. An air source heat pump extracts the heat directly from the air outside, and runs that through an expansion and compression process, which then delivers that heat into hot water, which can be run around your heating system through a standard radiator system. So they're definitely, I mean, we're moving out of the area of low cost alternatives here. When you're looking at renewable heating systems, they are generally a bit more expensive than a standard gas or oil boiler, but the running costs can be much lower, the environmental impact is much lower, and as I mentioned, with the renewable heat incentive, as we've got a bit of information on the slide here, they really can be a game-changing option. The renewable heat incentive is a UK government scheme, whereby, as I said, you get paid per unit of heat delivered into your building through a renewable heating system. It's quarterly payments. The rate that you get paid digresses over time, but it's fixed at the time that you commission your system. So if you were to install a renewable heating system and complete all the paperwork tomorrow, the rate that you're allocated tomorrow is what you're paid for the next 20 years, linked to the retail price index. Somebody who does the same installation 3 months down the line might be allocated a slightly lower rate depending on market performance at that stage, but once you're signed into the system, that's your rate fixed. And it's there purely as an incentive to help pay back the higher costs of that type of system. Generally, you're looking at about, with the RHI factored in, you're looking at about a 10-year payback time for most renewable heating systems in the kind of the small to medium size range. The next tip we're going to talk about is looking at your heating controls, having a good idea of when your system's coming on and off and what temperature your different spaces are running to is generally a good way to make sure you're only using as much heat as needs be. There are lots of different ways you can control your heating system. A simple timer like most people would have just in their home to set the heating to come on and off at set times in accordance with your working pattern or shift pattern, whatever happens to be the case in your own organizations. You can get slightly more sophisticated 7-day timers, so you can have different settings for different days of the week. Optimized controllers generally will